Good evening. Welcome to my laboratory. Can you see that? That's the schematic. This is a variation on Gadgetmall's 1/2 microamp Joule thief circuit. I wasn't able to get it down to that low current consumption because I probably don't have it built right yet. But I did notice some interesting things, so I made a couple of little variations to try to demonstrate that. The basic circuit is Gadgetmall's exactly with the component values that he used, except he used a 10 microfarad capacitor here, and instead of this little twisted pair gimmick, he used a 1 picofarad to 7 picofarad trimmer capacitor there. That's a 200K pot. That's a 0.01 microfarad. I used a polyfilm capacitor. And in my coil, I'm using what's called a ferrite bead. Let's see if I have one here. So I'm using one of these. This is called a bead, but I didn't wrap it like a toroid. I wrapped it just like a cylindrical core with 10 turns each and hooked those up like a Joule thief. And I'm using a 2N2222A transistor. And I put 2 LEDs in there back to back, an orange one and a red one, and they're wired like that. And then I have a little switch. I wasn't clear on Gadgetmall's schematic about where the anode end of the LED went. Normally it's connected to the collector coil junction, but he showed it connected over here to the base capacitor to this part. So I made a switch in there. I tested it both ways and found such interesting behavior that I went ahead and put a switch in there in the actual circuit so that I could demonstrate it live. And then I added another LED reversed, the red LED reversed from the original LED in the Gadgetmall circuit. Okay. So that is the schematic, and here is the actual circuit. I put it together a little bit differently, kind of just for fun. Let me see if I can. Sorry about the light. As you can see, I kind of incorporated the hole in the toroid as a battery holder. There's a spring down in there, so there's the coil. There's the little tantalum capacitor. I put another spring on the 2N22A transistor to act as a heat sink because it does get warm. There's the trim pot. There's the little twisted gimmick capacitor, and then I have it hooked up to some probes. There's the switch that I'll be using to switch between the orange LED and the red LED. That's this switch right here. So the LEDs will be switched either to the normal Joule thief point, the collector coil junction, or to the point over here that connects to the base and the pot. Okay. Alright. And I also have it hooked up to the trusty oscilloscope. So let me go ahead and just... Oh, and this is a current sensing resistor here. This is a 0.05 ohm 1% resistor, and I've got a scope probe hooked up across it, so we'll be looking at the voltage drop across that 0.05 ohm 0.05, that's right, 5/100ths of an ohm resistor. That'll be our current monitoring position, and then we'll monitor the battery voltage by looking at the positive of the battery and the negative of the battery, and we'll monitor that on the voltmeter up here. And then we'll also look at the output. We'll put a scope probe on the LED anode at this position here. So. Okay, so we're looking at the current across, sorry I didn't put it in the diagram, I should have I guess, at the current across current viewing resistor here, and then we're looking at the battery voltage here with the voltmeter, and then we're looking at the LED here with the probe at this point. Okay. Alright, so let me turn it on. Boom, right there. And you'll see with the, so right now I have the switch in this position. Or do I? Yeah. I have the switch right now actually in the normal Joule thief position. And if I switch it over to this position, I have it in the strange position over here with the diode reverse bias. This is the negative rail, remember. Right, negative rail coming in through here. Okay. So anyway, look at the scope traces. Alright, so the B channel is the, sorry about the light again, the B channel up here. This is where the baseline is, right here, that radical scale right there, and we're looking at that at 0.02 volts per division, no attenuation. So this is the voltage drop across that resistor. So that's 0.02, 0.04 volts, and it's a 0.05 ohm resistor, so we're looking at currents approaching an amp coming up through there. That's a pretty good little current draw. And then this is the voltage. Notice that the voltage goes negative. This is the baseline, right there. So the voltage is going negative, and this is at 5 volts per division here. So we got a little negative spike, and that's lighting up the red LED good and bright. Now when I switch the switch to the other position, that's this orange LED now, you can see now we have a positive voltage there of about 4 volts, and the current also shows that positive voltage. Okay, so let me switch the switch. Orange LED is on now. Red LED is on now. Orange LED is on now. Red LED is on now. So you see that the polarity of the voltage output actually switches. Okay, so I got orange. When the orange one is on, the switch is in this position. When the red one is on, oh, that can't be right. Duh. What the heck? I'm going to have to check this circuit to see what the positions are for the switch, because now I don't remember. I see that it could be either way. Let's see. Okay, normally the Joule thief, the anode is connected to the switch up here. So with the orange light on, normally that's the normal Joule thief configuration. When the red light is on, the switch is connected over here to the base of the transistor. That's the way it's wired. Sorry about the confusion. So right now the red light is on. We see that we're seeing a negative output, and that's the current. Now when I change the pot setting, it's almost like there's a this is really hard to do. There's a 2-mode situation here where we have, I'm trying to do this with my left hand. I don't know if the scope will stay triggered. As I change that pot setting, there's a critical point where things change. Boom, like that right there. See, so I'm just making a tiny little change, and suddenly, boom, the frequency radically increases, and you get this really nice looking current ring down on current trace there. It's beautiful. Right. Okay, so, and the red LED, of course, is glowing quite brilliantly there. A little bit more action going on the negative voltage there. Okay, now that critical point where the frequency changes from the lower frequency here, change the scope setting to the higher frequency there. Boom. That's happening in a really tiny range of adjustment of that. That's a 20 turn trim pot there. So I'm turning the screwdriver about a 1/16 of a turn to get it to make that transition. Now if I switch to where the orange LED is on, okay, we see kind of a similar thing happening, but really, really weird. With the orange LED on, if I get to one side of that line, I have the waveform that I showed you before. But then if I get to the other side of that line, that really fine tuning point, oink, oink. First there's an increase in frequency, but then we get down into this range here where the LED is just glowing really dimly. And what's happened to the trace is we've gotten to a much slower frequency and a smaller amplitude. So I have to change the scope setting a lot to capture it, if I even can get it to trigger properly. There. Unfortunately, it's not focusing on the screen. Okay, so that's pretty good there. That's a much, much slower frequency, and you can see that the current spikes are really narrow there. If I can get it to trigger right. And that's with a little dim LED. So in this mode, it's using very little current. But of course the bulb is also very dim. The LED is also very dim. Now I'm turning the pot down more and more. So you can see that the frequency gets slower and slower, so that means that the average current, change the time base here. So the average current is also going down, and the LED is still glowing. And as I go turn the pot more and more and more, you get the frequency slower and slower. The LED is still glowing. The battery voltage that we're reading is 1.25 there, which is interesting because the battery voltage is actually climbing. Anyhow, so I keep turning that pot and the frequency gets longer and longer. The LED still continues to glow a little bit. Battery voltage is showing the battery voltage. So longer and longer and longer. Those little bitty spikes, there's all the current that's being drawn. LED is still glowing. Still glowing. And we're still able to turn that pot a little bit more. It's a 20 turn trim pot, and we're still affecting the frequency there. I can still see the spike on the screen, and that's it. So we've reached the end of the trim pot travel now. That LED is still glowing very dimly, but I think you can see that it is in fact glowing. And the only current that we're pulling is that little tiny spike, and that is a really, really thin spike, and it's fairly tall here. This is at 0.005 volts per division, so let's call that 0.01 volt. And we have a 0.05 ohm, so that's about that spike then represents a voltage drop across the resistor of about 0.01 ohm or volt, and then that gives us about 0.002 amps, so that's 2 milliamps, and then that's in the spike, and then maybe that spike might be 100th of the period. So, is it still glowing? It is. That LED is still glowing dimly. On this minuscule current that won't even trigger my oscilloscope anymore. Okay. Thank you for watching.